Right now, millions of people are digging out from one of the most significant blizzards to hit the Northeast in nearly a decade. The snow is still on the ground, the power outages are still being counted, and the cleanup crews are just getting started. And yet, the atmosphere is already setting up its next move. A move that, based on current model data, almost nobody is talking about. Here is the thing. What comes after a storm like this is often just as important as the storm itself. And what the data is suggesting right now is not what most people expect. The question is not whether the weather is going to change. The question is how fast it is going to change and what that change is going to trigger across the entire country over the next 2 to 3 weeks. Let's get into it. First, let's establish a baseline. The Northeast just experienced a genuine bomb cyclone, a rapidly intensifying low-pressure system that dropped roughly 30 millibars in under 24 hours. That kind of pressure drop generates enormous atmospheric momentum. Think of it like a spinning top. Once it gets going, the energy has to go somewhere. It does not just disappear, it propagates. It influences downstream pattern evolution for days, sometimes weeks, after the initial event. So, what does that downstream evolution actually look like right now? Here is where it gets interesting. Following the exit of this nor'easter system, the models are showing a dramatically different atmospheric setup developing across the continental United States. We are talking about a pattern flip, and not a subtle one. The high-resolution rapid refresh model, the global forecast system, and the European model are all converging on the same general idea, which is that a massive ridge of high pressure is going to build across the central and western portions of the country. And historically, when you see that kind of ridge establishment after a major coastal storm, you almost always see consequences that surprise the public. Let's walk through what that actually means. When a high-pressure ridge builds across the central part of the country, the jet stream gets forced into a very specific configuration. Instead of diving southward and pulling cold Arctic air into the eastern two-thirds of the country the way it has been doing for weeks, the jet stream flattens out. It lifts northward. And when that happens, the cold air source from Canada gets cut off. The temperature gradient across the midsection of the continent collapses almost overnight. What does that translate to on the ground? Consider this. Within the next 5 to 7 days, the data suggests we could be looking at temperatures in the 70s and even approaching 80 degrees Fahrenheit across portions of the southern plains and the Gulf Coast states. Cities like Dallas, Texas, Houston, Texas, Oklahoma City, Oklahoma, and even Memphis, Tennessee, could be experiencing near-record warmth by the middle of next week. That is the same region that just days ago was dealing with temperatures well below the seasonal average. Now that alone would be surprising enough to warrant a conversation. But that is actually not the part that is going to catch people off guard. Here is what the data is really showing, and here is the part that demands careful analysis. When you get a ridge building in the central part of the country, and you simultaneously have residual moisture streaming northward from the Gulf of Mexico on the warm side of this pattern, you create the fuel for a severe weather season. And not just any severe weather season. We are potentially talking about the earliest significant severe weather outbreak setup that has appeared on long-range guidance in several months. Think about the ingredients. You need moisture. The Gulf of Mexico is loaded with it right now, and that moisture has nowhere to go but northward as the ridge builds, and the surface flow becomes southerly. You need instability. When you drive surface temperatures into the 70s that fast, after a prolonged period of cold air across the same region, you generate tremendous convective available potential energy very quickly. And you need wind shear. You need the difference in wind speed and direction between the surface and the upper levels of the atmosphere, because that is what gives thunderstorms the rotational capability to produce tornadoes. The question right now is whether all three of those ingredients are going to come together at the same time and in the same place. Based on the current 500 millibar pattern analysis, meaning the atmospheric setup at roughly 18,000 feet above sea level, the answer appears to be yes. And the timing window that the models are highlighting is somewhere between 7 and 12 days from now. Let's be clear about what the data is and what it is not saying at this stage. At 7 to 12 days out, no model on the planet can tell you exactly where a tornado is going to touch down. That is not how atmospheric science works. What we can say with reasonable confidence is that the overall synoptic scale pattern, meaning the large-scale atmospheric setup, appears to be evolving in a direction that historically correlates with severe weather activity. The Storm Prediction Center's own climatological records consistently show elevated tornado activity during periods of rapid pattern transitions from cold to warm regimes in late winter and early spring. This is a scenario worth tracking very closely. Now, let's move to the second major storyline that the data is developing, because this is the one that might generate the most headlines outside of the weather community. The western part of the country has been taking hit after hit from strong Pacific storm systems over the past several weeks. The Sierra Nevada mountain range has accumulated an extraordinary snowpack. The Cascade Range in Oregon and Washington has also seen significant accumulation. And the atmospheric river pattern, which has been funneling continuous moisture off the Pacific Ocean, has not fully shut down yet. Here is where the surprise element comes in for the West Coast. As the ridge builds over the central part of the country, it creates a downstream effect on the Pacific flow. The atmospheric river does not just disappear, it gets redirected. And the current model data suggests a potential shift in the track of incoming Pacific moisture, moving it toward a slightly different portion of the coast. Instead of the primary moisture plume continuing to target California as directly as it has been, there are indications that the Pacific Northwest, specifically Oregon and Washington, may be looking at a more active period of precipitation over the next 2 weeks. What does that mean practically? It could mean additional heavy rainfall at lower elevations in the Willamette Valley. It could mean significant snowpack additions in the Cascades. And given the wet conditions that already exist across the Pacific Northwest, there is a credible concern about flooding potential, especially in river valleys that are already running at elevated levels. Is that scenario locked in? No. The confidence on West Coast precipitation patterns beyond 7 days is low, but the directional signal is there and it deserves attention. Let's now look at something that is genuinely flying under the radar right now. And that is the potential feedback loop between the snowpack left behind by the nor'easter and the upcoming warmth. Think about this for a moment. Boston, Providence, New York City, Philadelphia, and the surrounding areas are looking at potentially historic snow totals on the ground. Some locations in New Jersey and Long Island could be dealing with 2 to 3 feet of snow accumulation once this blizzard wraps up. Now introduce a pattern flip that brings above average temperatures and southerly winds. What happens? Rapid snowmelt. And rapid snowmelt in an urban environment is not a simple process. When that volume of snow melts quickly, the water has to go somewhere. Drainage systems that were designed for normal runoff volumes get overwhelmed. River basins that have been elevated by earlier precipitation events get an additional surge of water. The Passaic River in New Jersey, the Raritan River, portions of the Delaware River Basin, the Connecticut River in New England. These are all systems that warrant a close watch over the next 10 to 14 days as the pattern evolves. This is not a flood warning. This is a scenario analysis, but it is a scenario that appears credible given what the data is currently showing. And it is the kind of thing that tends to catch communities off guard because they are mentally focused on the storm they just survived rather than what comes next. How do forecasters typically handle this kind of multi-hazard situation? The challenge in communicating this kind of cascading weather threat is significant. The public, and to some extent the media, tends to focus on one event at a time. There is the storm, and then there is the aftermath. The idea that the aftermath itself could generate a separate set of hazards does not always register until it is happening. That is something worth thinking about right now, before the pattern flip arrives. Let's zoom out even further and talk about what this overall pattern means in the context of the rest of winter and early spring. That is the larger context within which all of this data needs to be interpreted, and it is why the 2 to 3 week outlook demands more respect than a typical late winter forecast window. The nor'easter that just buried the Northeast is not the end of the story. In many ways, depending on how the next few weeks unfold, it may turn out to be just the opening chapter. Stay tuned. Watch the data, and do not assume that the most surprising weather of this season is already behind us, because based on what the models are currently showing, there is a real possibility that what comes next is going to catch a lot of people off guard. The atmosphere has a way of doing that. The past few days have proven one thing beyond any doubt. The atmosphere does not give warnings on a schedule that fits our expectations. A historic blizzard burying the Northeast, while the central part of the country eyes near record warmth and severe weather potential beginning to appear on the long-range guidance. This is not an ordinary late winter pattern. The data is telling a story that demands attention from everyone, not just weather enthusiasts. Stay informed and stay prepared. If this kind of deep dive pattern analysis is what you want to see more of, hit that subscribe button and turn on your notifications right now. Every day the models update, and every day the story changes. You do not want to be the last one to know when the next major setup starts taking shape. Drop a comment below and tell me which part of the country you are watching most closely heading into the next 2 weeks. Let's talk about it. The models are currently showing a warmer than average regime settling in over a large portion of the lower 48 states for roughly 2 weeks starting around late February. But, and this is a critical but, that does not mean winter is over. Pattern analysis consistently shows that these warm intrusions get followed by cold rebounds. The cold air does not disappear. It gets pushed back into Canada temporarily, but the source region remains there. And when the ridge eventually breaks down, which it will, the cold air comes back. The question is what the atmosphere looks like when that cold air comes back. If we are sitting in a pattern that has generated significant Gulf moisture return, significant snowmelt runoff, and elevated soil moisture across a large portion of the country, and then a reinforcing shot of cold air drops southward into that environment, the potential for high-impact weather increases substantially. That is a setup that, looking out beyond the 2-week window, appears possible based on the current long-range guidance. Again, this is scenario analysis at a range where confidence is inherently limited, but the ingredients are on the table. The atmospheric energy that drove the historic nor'easter we just witnessed does not simply vanish. It continues to evolve. It continues to influence what comes next. And what comes next, based on current data, has the potential to be just as impactful in its own way, even if it looks completely different from the blizzard we are still processing. One more piece of this puzzle deserves attention, and it is the one that most people are not even thinking about right now. Temperature records. If the ridge scenario plays out the way the models are currently suggesting, there is a legitimate possibility that portions of the southern and central parts of the country could challenge or even set all-time late February temperature records within the next 7 to 10 days. The Energy Information Administration and agricultural interests across the southern plains will be watching this closely, because a rapid warm-up following an extended cold period has direct consequences for winter wheat crops, for livestock operations, and for energy demand management. Those are real economic considerations tied directly to what the atmosphere is about to do. The weather does not operate in a vacuum. Every significant pattern shift has downstream consequences, both meteorological and societal. And right now, the data is suggesting that a significant pattern shift is underway. There is also a lesser discussed element worth analyzing here, and that is the role of the stratosphere. In the weeks leading up to the nor'easter event, there was documented evidence of a sudden stratospheric warming event, meaning an abrupt and dramatic warming of the stratospheric layer, roughly 30 kilometers above the Earth's surface. These events, while not directly causing surface weather, are well documented in scientific literature as being associated with disrupted polar vortex patterns. When the polar vortex gets disrupted by a sudden stratospheric warming event, the downstream effects on surface temperature and storm track patterns can persist for 4 to 8 weeks. This is not speculative. The scientific literature on sudden stratospheric warming events and their connection to cold air outbreaks and pattern disruptions in the mid-latitudes is robust. What it means practically is that the overall atmospheric environment we have been operating in, the one that delivered the historic nor'easter, the back-to-back California systems, the Ohio Valley severe weather threats, is not a random collection of events. These are all interconnected manifestations of a broader pattern disruption that began weeks ago in the stratosphere and has been propagating downward into the troposphere, which is the layer of the atmosphere where our weather actually lives. Understanding that connection matters because it changes the way you interpret what the models are showing at long range. A pattern that is being influenced by a sudden stratospheric warming event does not behave the same way as a normal seasonal transition. The cold air rebounds can be more abrupt. The warm intrusions can be more extreme. The severe weather setups that emerge from the collision of those two air masses can be more intense than what you would typically expect for a given time of year.